Okay. So we're going to talk about cardiovascular. So the cardiovascular system itself and cardiovascular disease is the #1 killer in America. Counts for 1 in every 3 deaths. Obviously, everybody who dies obviously dies from cardiac arrest, but the disease itself has been the #1 killer of Americans since 1900, more so than war or anything else. Okay. The way that we get involved with people and actually reduce the number of people who die from said diseases is by encouraging a healthy lifestyle. So public education is a large part of it. Access to medical care, or early access to medical care, through things like community paramedicine and other programs. More CPR training of lay people. That's a huge initiative, and even our company does that, getting out there and training people in hands-only CPR. And then technology and dispatch and response. So getting people to where they need to be faster is saving lives. It has a huge part to do with it. Also, public access to defibrillators, making sure that the right machines are in the right places, knowing when to call for ALS. That's a huge part of what our job as EMTs is, you know, when do we get to a point where our resources are taxed and now we need something more. And then cardiac specialty care centers. Lucky for us, we have 2 right here in this general area, being St. Joe's and Memorial. Okay. So the anatomy and physiology of the heart. We're going to talk about 3 things today in particular. We're going to talk about the pump, we're going to talk about the pipes, and we're going to talk about the fluid. The pump being the heart, the pipes being the blood vessels that carry the fluid, and then the fluid itself. Okay. And I'm going to break them down. We're going to talk about left versus right. We're going to talk about those 21 points of circulation again. Remember that. So all those things will be part of what we're going over. Okay. The little red dot is on, all right? Okay. All right. So this is just a picture of what the cardiovascular system actually looks like. And the blurry picture. That better? Okay, so the atria. Your heart has 2 atria, left and right, and this is what receives blood. Okay, the atria receives blood, pumps it out into the ventricles through the valves, and the ventricles pump it out to either the lungs or the body. Left pumps it to the body, right pumps it to the lungs. Okay, there are one-way valves inside of the heart, 2 of them, that allow for blood to flow in just one direction. The aorta, which is the main artery in the body, pumps blood from the left ventricle to the lower portion of the body. Okay? And this is kind of how that process works. We talked about the 21 points of circulation before, but we're going to go over it again here in just a little bit. Okay? The heart has an electrical system. Okay? This electrical system controls 3 things. It controls rate. It coordinates the ventricles and atria in the way that they fire. Okay, so what it controls specifically are 3 things. They're known as inotropic, chronotropic, and dromotropic responses. Okay, what these are: chrono being time. Okay, dromo being impulse. All right, and ino being the strength of contractility. Okay. So we're talking about the way that the heart actually squeezes is based off of these 3 things. All right. Automaticity itself is spontaneous contraction. So the heart has a nerve called the vagus nerve, okay, that runs from the brain to the heart, and it controls the intrinsic rate of the heart. But the heart itself pumps and creates its own electricity. Okay. It creates its own electricity. This impulse comes from the SA node, okay, travels down to the AV node, and then from the AV node down into the bundle of His, and then the Purkinje fibers. And that's what causes that electrical contraction that causes the muscles to squeeze. We're going to talk about that more in just a second. If that impulse doesn't arrive, other cells are capable of creating their own impulses. The SA node, and write this down, is the primary pacemaker of the heart. The heart has what we call pacemakers. These are the things that set the rhythm and the quality of the heart and the way it beats. Okay? And I'll write down for you what those are, and then I'll go over them as a whole. Okay? We have the SA node, which means sinoatrial. Okay? That's above the ventricles. I mean above the atria, excuse me. You have the AV node, which is between the atria and ventricles. Okay? Then you have what's called the bundle of His, and it's HIS. Okay? That's below, or excuse me, at the top of the ventricles. This is what begins the contraction of the ventricles. And then you have the Purkinje fibers. And those are Purkinje. And what the Purkinje fibers do is they're throughout the ventricles. And in the next slide that you're going to see, you'll see exactly how that works. Okay. So the SA node is above the atria. You see that here. Okay. It's above the atria on the right side. Okay. Then you have the AV node, which is right at the junction of where the atria and ventricles meet. Okay. Then you have the bundle of His, which is at the top of the ventricles and causes the beginning of the contraction of the ventricles. And then you have the Purkinje fibers, which are these here, okay? And what those do is that sends that impulse on down through the ventricle to cause it to squeeze all the way down, okay? So SA to AV, AV to bundle of His to Purkinje fibers. That's the way the contraction works, okay? SA, AV, AV, bundle of His, Purkinje fibers. Now, when you look at that picture, the one thing you see is that, if you look at that picture, you can see that the actual left atria doesn't actually have anything to cause it to contract. It does. The SA node has one, what they call internodal pathway, just like this, that comes across, called the bundle of Kent. It goes over there and it just stops right here. And that's what causes the left atria to fire. This is what causes the AV and the bundle of His, is what causes the left ventricle to fire. Okay? So the impulse starts here, goes over here, you don't see it on this map, but it goes over here and stops, and just causes that to squeeze, and then the blood flows through, the impulse is picked up down here, and flows through the rest of it, and that's what causes the left ventricle to fire. Okay? All right. You got a question?
Why is it not one showed?
On this map, they're talking about the basic flow path of how most of the electricity goes.
Okay.
That's something separate.
Okay.
I just like to add that in because that technically should be part of it. But this is just one constant flow path here.
So it's just like it's just got another one.
Just goes over to the side and stops.
Okay.
Yeah. Okay. All right. So all of this works through what's referred to as autonomic controls, okay, which are involuntary. That means it does it on its own. We don't control it. It just is what it is, okay? The autonomic nervous system has two parts to it, okay? There's two parts to the autonomic nervous system. The first is known as a sympathetic nervous response or a sympathetic nervous system. The secondary is known as the parasympathetic. Now, the sympathetic is what is known as fight or flight. Okay? The fight or flight response means that in the instance of us being scared, us being concerned about something, we're either going to get ourselves ready to attack or we're going to get ready to run. One of the two. So what happens in this instance is we get tunnel vision, our pupils constrict, our blood vessels also constrict, allowing increase in pulse rate, so that way, and the heart starts to pump harder because we have increased oxygen demand, okay? So that's what happens in a sympathetic response. Then you have on the flip side of that, the parasympathetic response, and para meaning opposite, right? The parasympathetic response is what I like to refer to as the Barry White syndrome, or the feed or breed response is what it's actually called. This is where everything slows down. Your vision becomes very wide. You become very relaxed. Your blood vessels dilate. Your blood pressure and pulse rate go down. And one of the things you see with this here is how people, and I always like to point this out, people talk about when they, are around somebody they love or care about, that they get butterflies in their stomach. What actually is happening is that the rate of undulation within your bowels is slowing down. So what actually happens is you're getting gas. So, the being around the person you love gives you gas. That's exactly what happens. Okay? So the myocardium, which is the heart muscle, myo being muscle, cardium being heart, have a continuous supply of oxygen and nutrients to pump blood. Has to have oxygen. Just like the brain has to have oxygen and sugar, the heart has to have oxygen. If the heart has an increased oxygen demand, the blood vessels will dilate, especially the blood vessels of the heart. The heart has its own blood vessel supply. Okay? The stroke volume, okay, is the amount of blood that is moved with each contraction. Okay? Increased stroke volume results in increased cardiac output. So the more blood that's ejected from the heart with each contraction means the heart is putting out more blood. More blood is required, more oxygen is required, more blood is being put out. Okay? The coronary arteries themselves are blood vessels that supply blood to your heart muscle. Okay? They start at the top of the aorta and just above the aortic valve. Okay? And the right coronary artery supplies blood to the right atria, right ventricle, and in most people, the inferior wall of the left ventricle. So it wraps all the way down to the left side, from right all the way down to left. Okay? Yeah, right to left, in reverse. The left coronary artery supplies blood to the left atria and left ventricle, and divides into two main branches, just a short distance from the aorta. So very close to the aorta, it splits off into two, and it becomes a circumflex artery. Okay? So we're going to talk about those. And this is a kind of a picture of those there. Okay? You see just shy of the aorta, right here, is where it bifurcates or splits off. Okay? And becomes what's known as the circumflex artery. Okay? Or one of the circumflex arteries. Alright? You have several major arteries in your body that supply blood, okay, to different parts of the body. You have the right and left carotid arteries that supply the brain. You have the right and left subclavian arteries. Those run just under your clavicles, okay, supply all your upper extremities. You have the right and left subclavian. Those supply the upper extremities. You have the brachial artery, which splits off from the subclavian and feeds the arms, okay? Then you have the radial and ulnar artery that splits off from there. The radial and ulnar artery split off. One goes along the radius and one goes along the ulna, okay? And so those split across and feed the hands. Then going lower from your aorta, descending aorta, you have what's known as the right and left iliac arteries. Those supply your groin, the pelvis, and the legs, okay, or the top of the legs. The right and left femoral artery split off from there and supply the lower legs, okay, or the thighs, excuse me. And then of course you have the anterior and posterior tibial, okay, which supply the lower legs, okay, and the feet. So you have all these splits that go down and provide you with all that. And actually, if you look in your book also, and in your the PowerPoint slides you have on JD Learning, it gives a good breakdown of all of those. Okay. The arterioles. Okay, so remember, it goes arteries, arterioles, capillaries, venules, veins. So arteries are the largest. Arteries, arterioles are smaller. Capillaries is where gas exchange takes place, whether at the heart, whether at the lungs, whether at the organs, whatever. And then it goes venules, which carry deoxygenated blood. Those are smaller, and then veins, which are larger, and those go back to the heart, okay, or back towards the heart, okay. So arteries, arterioles, capillaries, venules, veins, okay. And when that blood goes back to the heart, it goes back to the superior vena cava and inferior vena cava. If it's at the top, if it's coming from the top of the body, the head, the arms, it goes into the superior vena cava. If it's coming from the bottom of the body, it goes into the inferior vena cava, okay? So we got to make sure we know where that blood is coming from, all right? And this is where it gets fun. Now we're going to talk about, we talked about the pump. Now we're going to talk about the pipes, or the fluid itself, okay? We talked about the pump. This is where we talked about the pipes. Now we're going to talk about the fluid, okay? There's 4 different parts to blood, okay? The first part of blood is red blood cells, okay? Red blood cells carry oxygen and remove carbon dioxide. They carry oxygen and remove carbon dioxide, okay? All right, carry oxygen, remove carbon dioxide. The next one we're going to talk about is white blood cells, okay? White blood cells fight infection. These are known as leukocytes, 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 okay? Red blood cells are known as erythro, Erytho, Erythocytes. Erythro just means red. Cytes means cell. Okay. Leuko means white. Alright? And cyte means cell. Alright? These fight infections. These are also known as T cells. Okay? So when you hear diseases like leukemia, it is an infection that has affected the white blood cells and caused them not to be able to fight off infection. Okay? Then we have what are referred to as platelets. Now platelets are what help us clot. Platelets move into the bloodstream, rupture, release what's called fibrin, and that's what makes the scabs that you see on your wounds. Okay? So if you have a wound, that's what happens when the platelets are sent to that wound site, is that they release fibrin. Okay? So we talked about erythrocytes.
Can you say that platelets?
Yes. Platelets break apart and release what's called fibrin. Fibrin, fibrin. And what happens is that's what forms the clots or the scabs that you see on your skin when you have an injury, is the fibrin, okay? The other side of that you'll see plasma. Plasma, the best way I can explain plasma is it is the Uber of the body, okay? Plasma is what makes everything move, all right? Plasma is 70 to 75% of the total blood composition, okay? Everything else floats in plasma. When you become dehydrated, the first thing to go is plasma, okay? Meaning that if Uber's not running, nobody's moving, right? That's why I use that, because that's how I remember it. So, When you have an injury, just